Hi, in this video I'll be showing you how to build a robot car simulator by using multithreading in C++. Now, depending on if you have Windows or Mac, you may not have the threading feature. If you are on Windows, you may have the min.gw compiler. For that, you can install threads from this link below. However, if you are on Mac, you will most likely have the Clang compiler which natively supports it. So multithreading is a very popular programming method to speed up your program and to run different threads at the same time. In this simulator, you will see that we can run two objects, or like basically two cars, in a same manner by using different parameters. So it'll be quite an interesting program, and let's start. We will be using the kinematic bicycle model for the dynamic simulation. This is very commonly used for control system design for driving because it gives you a good understanding of the mechanical behavior of the car. There's 4 states here, X and Y, which correspond to position, V for speed, and psi for the heading angle. There's 2 inputs, U1 and U2. U1 is the acceleration and U2 is the steering angle itself. And beta is the slip angle, which is respective to the speed vector. The diagram very clearly shows the whole representation there. It's quite a simple math model, not too complicated, because you can very easily do simulations and control design from this. The values LF and LR correspond to the distance from the center of gravity to the front and the rear of the car respectively. We'll be using gnuplot to visualize our data because it lets you very quickly plot from a text file. You don't have to use it, but I do recommend it because you can simply plot from the command line. You don't have to use Excel or MATLAB or any other language to parse the data first and then plot it. gnuplot is built specifically for the command line itself. Okay, let's begin with the program now. Let's create a bunch of files here. You have car.cpp, main.cpp, and car.h. Before I actually start off with the simulator, I'm gonna do a small test here. If you are using VS Code on a Mac, you may have to make a configuration change to the file because it may give an error. So let's first actually test the threading tool. For now, just do a cout hi and then, like any text you want to, and create a function there. So actually I'm going to run this first and then just go to my compiler. I use Clang on Mac OS. It's very popular. It's quite nice actually because it includes everything. So it worked. That's good. I'm going to go to my VS Code tasks file, tasks.json. Let's make a new function there called cout any text that you want, and I'm going to use a thread that will call the function and then just run it. So just mention thread t1 is equal to function1. That's it. It doesn't take any arguments, and then join it. So when you join a thread, the main thread will stop executing until you finish this one. And okay, here, so now I'm going to add 2 more commands in the arguments panel, in the arguments tab. So I'm going to say standard C++ 17 because since that's the one I'm using, and then write standard library equals library C++. So this means that I have everything from the standard library I can use here. If I didn't do this on Mac, it'll cause an error. So far, things look good. So in my task file, I need to add 1 more file, which is the car file, because this only will read main. You have to add any other files. Again, this is only for Mac. For Windows, I'm not sure because I don't use Windows anymore. So yeah, I'm a Mac person now. So yeah, any other files other than main, you need to include it there. Okay, now we can actually begin the car class. So let's include everything that we need and create a class here. So public and private. For private, I'll use step time dt, front distance, rear distance, slip, acceleration input, and steering angle. For my states, I'm going to put them in public variables because It's much faster to just access them directly. Keep in mind that in C++, if you want to access a private variable, you have to actually use a method to return it. But I don't want to waste time doing that here. I just want to demonstrate that you can actually use threads to create a simulator. That's the whole point. So let's add the methods that we need to. Set constants, which is the front and the rear distance. Set initial conditions, your initial speed, location, and so on. Set inputs and simulate trajectory. Also write to file, because we'll be putting all our outputs in a text file from which gnuplot can plot the data. And I have my vectors there, which is arrays, same thing as a vector, x, y, positions, speed, heading, and I have one more for time. So let's complete this class file now, include car.h, and then create the constructor. If you notice, we have a constant value in our car file, so we need to actually initialize that by doing a member initialization list. So dt and then 0.01. In C++, if you want to initialize a constant, you have to use this. You cannot just use it in a method. But for the other parameters, we can call set constants and then assign the values there. I'm just going to copy and paste along so I can save time. So we can now finish off these methods here. Let's also add the car annotation so that it knows that it belongs to the car class. For my initial conditions, I'm simply appending the initial x, y, v, and psi to the vector. So I'm going to say push back x of I, y of I, and so on, along with time. For setting my inputs, I'm going to simply say set the acceleration and steering angle. So for now, these values do not change with time, but in your simulator, if you want to change it, it's quite simple. Just make them a function of time and don't have the method there. Okay, simulate trajectory, this one. You have to first get the number of samples that we need and then do it in a loop. We'll be using Euler's method, quite straightforward. I've made so many videos on that in the past. Euler's method is very useful for simulating differential equations. It is less complex than the RK4, but it's quite robust for in here because we don't have very complex dynamics. So we have to update time, position, speed, and so on. So I'm simply using the Euler's method for formula, which is the step size multiplied by the function plus the initial value. And you just keep appending it over and over again. So I did it for time, for speed, for slip angle, for heading. And then lastly for x and y. Now let's move on to the write to file method. Okay, so to write to file, we need to use file streaming. So OF stream. Let's create a file, open it. It'll take an argument file name. And then you simply have to just output the headings. So we have time, x, y, speed, and heading angle too. So we need to include all of these here. I will tab space them. I won't use commas because commas will look a bit messy. I feel that tabs look a lot nicer. So to space things by tab, just mention forward, slash, and T. And I'm going to output all my values in a loop. O file, set position 5, time, x, y, and so on. So this is like cout. I'm just outputting everything to the file. And then I close the file after. So we can now go to the main script and continue with our program. So let's remove that function 1 along with the T1 joining, because I'm going to actually redo everything. So create a car instance, set the inputs, set the initial conditions there. So for now, I don't have any heading angle. It's 0. And my steering angle is 0, 2. So I have an acceleration of 1.5 meters per second. I have 0.03 seconds as my time. I'm going to let the file name be car1.txt. Now make a second object, car2. So set the inputs to anything you want to. You can have them simulate with different times. That's the whole benefit of using a thread, because you can actually use separate parameters and instances. You obviously have to create a second object, because if you use the first object and the second one, it'll just mess it up. And you want to have separate instances. So if you do have threading, then use it. But if you don't, that's still okay. You can simply call the method simulator and then write to file separately in sequence. But let's actually use threading, since that's the point of this tutorial. Okay, this one, I'm going to create 2 threads there, thr1, thr2, and then join them after. I'll explain everything as I go along, so let's just create them first. Now we need to do this in a specific way. We have to first mention the method of our class, which the thread will call. So it's going to be car, which is the pointer, simulate trajectory. I pass in my car1 by reference as an object, and then I also pass in my time as a reference. There's no need to make a copy of it. Simulate trajectory takes in an argument time, so we need to pass in the arguments separately, right? So you don't actually write brackets and then time. You have to pass it in separately as a reference. If you call a function inside of a thread, you have to do it this way. Otherwise, you'll get errors. You see how in my simulate time, I have a time value there, double t. That's my t1, right? So that's the argument I'm passing into it. If you have more arguments, just put commas, separate them by commas. So t1 or comma anything else. And for the second thread, same thing. t1 is t2 now, and then car2, because that's my second object, and then join them. I realized I didn't make a mistake. I realized I made a mistake. I need to include red first, so it doesn't like error out. So I'll quickly do that here. In fact, I can put this in the car file, so it looks less messy. So now it should be good. So we have 2 objects and 2 separate threads, which will both begin at the same time. So let's run our program. You should get no errors. And if you go in the debug console, you will see that it ran successfully. Let's actually output the speed at every iteration, because I want to demonstrate that these threads actually run at the same time. So to do that, just write cout inside of your simulation method, speed of I. So it'll output every speed value and then go to the next line. So now if I run this again, you see how now we have 40 and 20. So the 40 corresponds to car2, right? And 20 corresponds to car1. If you look at the initial conditions, you will see that I set 20 and 40 as my speeds respectively. That's the third input. So even though I set t1.join first, it actually printed the second thread, because the second thread ran faster than the first one, so it printed that first. Let's actually run it again. And now you see, okay, so now I made the time longer, so it prints out more values. But again, thread 2 printed out first. But does it mean that it'll always be this way? Well, let's find out, right? So let's run it one more time. Okay, now what's happening? Now we have 20s and then 40s, and then if you look below, you have 20s again. So it's outputting thread 1 and then thread 2 and then back to thread 1. It's not sequential. This means that they both run at the same time. They both call cout and they both will run it. And that's why you see that the values are mixed in now, right? It's not that the values are destroyed or anything. It's just that since they both run at the same time, I will call each object's array. and it's printing out 20s and then 40. It goes from 40 to about 39.86 and then it jumps to 20. Let's run it one more time. Okay, now you see how it's like 20 first, so that's car 1's values, and then car 2. So now it did that because I said thread 1 before thread 2, right? So now I'm calling thread 2 after thread 1. So it's going to wait till thread 1 is done and then join it. Let me actually flip it now. So let me put the first thread to be joined, but only after the second one is done. So I'm going to try this here. So now if I run it, you will see that the second thread will always run before the first one because I call it only after it's joined. So keep in mind that if you want the threads to begin at the same time, you must join them sequentially. You cannot call it after joining it. You have to join them like this here. So this might be a little confusing, but the moment you call join, the main program waits until the threads are done. So here I'm joining two separate threads, so they both will finish and then the main will end. So you see it now, it looks a little funny because I have the 20 in there just like jumped in. So yeah, it just proves that they both run at the same time if they are joined immediately after another. So I hope this demonstrates you how the threading works. It is a lot more complex than this. I will make more videos as I go along. I will cover more advanced topics, but this was the first exercise. Okay, let's take out the printing now and then let's normally do it. Now I'm going to actually write to file and I'm going to call two more threads to accomplish this. So I want to create two text files, car1 and car2.txt, which contain the outputs of x, y, and speed and everything else. So let's do that here. thr3 and 4, call them as objects and join them once again after another so they both run at the same time. So the method now is write to file, and it takes one argument, file name. So we have to write ref file1 and then file2. I declared those above in strings. Let's comment this out. I want to show you one more thing here. Let's put car1 in the second thread. This will create a massive error. So you see how it did sigbart. So if you have two objects and you have two separate threads which are trying to work on the same object at the same time, so this is obviously not good and it'll give you that error. So that's why I have car2 in there. Now if I had car1 with a massive array and I'm accessing different values, that's fine, but now this time it gave that error because it was referring to the same exact memory space at the same time. So let's uncomment these ones out now and then let's run them. So we have two files made there, car1 and car2.txt. Let's open them up. It looks a bit messy here because it's in VS Code, but if you use Notepad or something else to open it, it should look fine. The tabs make it look a little strange, but it does look quite neat. You have time, x and y, and speed and your heading angle shown in columns very neatly. I'm going to make the times longer and then run the program one more time. It should overwrite what you already have in there because I opened the file and I write from the first line. So yeah, now you see that we have a lot more data in there. That's good because we have more time, right? So yeah, you can try different parameters and see what you get. When you're happy with this and you want to visualize it, you can use gnuplot and I will show that soon. So that's our output there. It looks quite nice. If you open it inside of a text file, it looks a lot better than VS Code. You can see how it's nicely spaced there in tabs. And now let's plot the data. So just go to gnuplot. So to do that, we have to go to the terminal and then go into the folder that we have our files in, as you can see here. Now, if you just call the plot command straight away, it's not going to work because you have to actually type gnuplot and then press enter. I'll show how that works now. So if I just say plot text file, it's give you some error, right? So gnuplot, press enter, and then it should give you this prompt here. If it installed correctly, it should give you this here. And then now you can actually use the commands. So there I'm plotting my speed versus time. Now the exact syntax for gnuplot, just Google it because there's so many different ways to plot data. It's all out there on Stack Overflow and many other sites. I just got it from that. But the basic idea is that you have to write the file name and then say which columns you want to display along with the labels. So here I'm going to write 2 because I want to plot X and Y, so X and then Y on the Y-axis. You see how since we have a steering angle there, the car is like turning a bit? Because I had a non-zero steering angle for car 2. So yeah, it looks quite nice. And now I'm going to plot everything for car 1. So all my data, X and Y and everything else. And I'm going to use the first line as the header. So if I run this one here, it should show you the headers inside of a legend like that, X, Y, V, and psi, because it takes it from the text file itself. So that's one more benefit of using gnuplot over Excel or MATLAB or something else. It's very quick. In one command, you can plot your data. And yeah, that's it for the video, essentially. So I hope you learned something new, and I had a great time making this video.